I'm here to talk about a technique called event sourcing and how it can accelerate or enhance the way you look at your data with Groovy. So let's talk about how your company gathers data about its users. Now, I have here a fake person that I called Bob. Your company may have somebody like this guy. His job is a web analyst. So he spends his days trying to look at information that your company collects about how your users navigate through your site to try and figure out information about what they might be looking for, what might be best about them, what they're into, and how you can improve their experience on your site. But Bob's job is very difficult. He spends his days looking at things like click streams or page visits in order to figure out what your customers want. He uses tools like Google Analytics, IBM's Core Metrics, and Adobe has a product which is appropriately named Adobe Analytics. So the majority of these systems work by you having to sprinkle your site with a bunch of script tags, which make asynchronous calls to these third-party systems. They're asynchronous, but it's sort of messy. You have to sprinkle this stuff all over the place, and it feels a little bit dirty. Furthermore, it gives you a very wide view of your users. You can't learn it's difficult to learn anything particular about specific users. That being said, if anyone's used New Relic, it's really incredible. And I wonder if they'll see this and give me a commission. You should ask yourself, what do you have in your systems that can save Bob from this third-party nightmare? Imagine if he had an integrated solution within your application that he could use to get enhanced data about your users. So let's take a look at the current systems that are out there and see how you're persisting your data. Now, is anyone here using a large MVC framework in their application in some capacity? Yeah, probably Grails, Rails, Django. And these systems are all wonderful, right? Fantastic. But they tend to promote a structural or snapshot model of storing data. And basically what that means is you take your domain object, and these systems basically take your data and save a static snapshot of the state of that object at any given time. And it generally maps to one row in your database, which, is fine, probably. Yeah, but what could possibly go wrong with that model? Well, let's take your bank, for example. Imagine you go online and you log into your bank and you want to see what your balance is, and all you see is the balance. Say you're looking to see if your paycheck got cashed. All you see is a number, right? That's not great, especially if it's negative. You'd want to know how it got there, right? What? Why? How'd this happen? But imagine if the bank couldn't tell you that, right? But that's not how banks work. They keep track of everything that happens to your account, every credit, every debit, every addition, and they store that information as a row. So it's not simply the balance itself. They calculate the balance by going over and adding and subtracting all of those numbers. So for some domains, this temporal, time-based data, the journey, is more important than the end result. It can tell us how we arrived at the destination. A good deal of power in that. There's a phrase in English, it's not the destination, but the journey, which means that often the end result is a bit empty maybe, but the knowledge you gained along the way is what really is important. So maintaining only the current state can be a bit of a limitation, and the historical data can be very, very useful. And we can use a technique called event sourcing, surprise, surprise, to achieve this. Now, in event sourcing, the first rule is that there's no direct manipulation of state in your database. There's no updates. Instead, we alert the system about all events that happen for a particular domain or a set of data. And these events are tracked and recorded in the order in which they happen, along with any relevant information about that particular event. So it's a bit like a newspaper. We get to know everything that happened during that event. So in a sense, these events become a timeline of your object. And I think that's a very powerful statement. Now, if you step back and think about what we can do if we maintain the entire history of a particular instance or all the instances of our data. We can go back at our domain object's timeline and examine it, and this is supposed to be a series of events that lead up to the current state. So we can go back at any point and look and see what the state of our object was at any given time frame and get back the current state. And if at some point we note that there's an error or a discrepancy, like say we had two events that conflicted with each other, they're both trying to change the name or something like that, we can, if we find this, we can go back and apply another event which fixes that error. Furthermore, if we want to get even crazier, we could go back to a specific point in our data's timeline and then fire fake events to simulate an alternative time path. Now this is really useful for testing, right? If I know that my system's having a bunch of problems, I can go to a specific, and then create a bunch of fake events to see what would happen to the system, and then plan for that accordingly. We can also continuously play back our events to view our data like a movie. But what I'm really focused, or what I'm really talking about now, is ultimately getting the current state of the object. And the current state of an object is only one projection or view into what's happening. And it's possible with that timeline to look at the data in different ways. So I could go through and grab specific events and group them, sort them, look at them in a different manner. But this is all hurting Bob's head. So I'm going to give you a specific example, a shopping cart. I think that's a perfect use case. Or rather, an e-commerce shopping cart. So here is my Amazon cart. I'm looking for coffee. Big fan of coffee. Especially the coffee you guys have here. In the US, the coffee is very weak. As users browse the application, they're adding products, they're removing them, they're checking out that the little euro symbol is supposed to be they purchased. We can not only can we look at the data for specific users' cart and see how they arrived or what products are in there, but we can look at all users' carts. Now, knowing the history of everyone's cart interactions and how they relate to each other in time, we can create projections or views across these event streams in order to find a variety of patterns within it. So, for example, if a user was adding a product and then removing it, maybe the next day they add it again and then they remove it again, maybe they're deciding whether or not to buy this, and maybe we can send them a little offer to push them over the edge to actually purchase the object. We could look at events over time to see how if a user is adding a product and then they're taking a lot of time between going around and purchasing it, or if they're immediately clicking on a product and then going to checkout immediately after that, maybe we could add a quick a one-click purchase button, just like Amazon has, to save the user some time and increase their interaction. So with all this information, Bob's pretty happy, because now he knows exactly which users are doing in the system at any given moment, and he can take that information and relate it to other things that are happening from the system. And using these third-party tools, there's a lot that he can help predict about your future behavior and enhancements he can suggest for your systems. Now, event sourcing is not a new concept. It's been around for quite a long time, and you'll find it in a variety of places beyond just software. So again, banks, for example. Every deposit and withdrawal is recorded as an event, just like I said earlier. Git, source control. If you saw those timelines earlier and you thought that looked a bit like a Git nightmare, this is what Git is based on, this concept. In fact, I was at a conference a couple weeks ago, and there's a guy from GitHub talking about advanced branching and rebasing techniques. And the entire time he was showing charts just like I had. And I'm sitting there going, whoa, I gotta talk to him. So I ran up to him afterwards and was just badgering him with questions and trying to explain this stuff to him in the space of about 5 minutes. He got a little overwhelmed and he stepped back and he gave me a copy of his book to make me go away. And so also database transaction logs follow this concept too. And so if you're thinking, well, wait a minute, if I already have this information, why would I need to do anything else? I mean, it's sitting in the database already. I could go through all these logs, and I could build a little tool that combs through my SQL logs and do exactly what you're trying to get at. And that's true, you could, but audit logs tell you the history of what already happened. And events, and incorporating events into a first-class system or first-class member of your system helps tell you the intent of the history and what the users were trying to do. And if you're using an event-based system like Netty or Ratpack or some alternative architectures, they marry well. So hopefully that seemed pretty interesting, but how do we go about doing this? So I'm going to give an example that mimics something that Martin Fowler uses when he talks about this very same subject. Let's use an airport. So I'm going to use some UML here, so I apologize if this is annoying. So let's say our system was involving airplanes, and we wanted to track where airplanes were at any given moment. And we can have an airplane object, or an airplane class that keeps track of its designation, its call sign, its name, what type of plane it is, and its current location. But what's the use in only knowing where the plane is now? We might want to know where it's been, where it's going throughout time. If we weren't using event sourcing, all we'd have is this airplane class. We might have an air traffic control service, which records arrivals and departures, and in doing so, it then adjusts the location on the airplane class or instance. Now, if we wanted to use event sourcing, we'd have to expand a little bit. So instead of the control service manipulating the airplane directly, it fires off an airplane event, and then I have two subclass types there, an arrival event and a departure event. Now, each of these events maintain information about what just happened, which airplane was there, which airport it was at, its location, and this is the key part, a function that it uses to manipulate the instance of the airplane itself. What we can see here is that the control service never actually directly touches the airplane. The events manipulate the object in memory. Whenever the plane takes off or lands, the air traffic control service generates these events. We can emit them throughout the system, or we can simply call them in memory. These generically named process functions on the events could actually be very complex. They could do checks to make sure that everything's acceptable with what's about to happen in the event, throw an exception if something was wrong. Ideally, these services should be responding to some task that was issued by an end user. So the air traffic control service is not going to just start issuing commands. It's going to wait and get approval from the tower to make sure that the plane can take off, and then issue an event. And so what ends up happening is that we end up with a series of these events, one for each plane. Arrival, departure, tons of them. And as the single plane travels around the world, arriving and landing at each of these different airports, we start building this incredible amount of data about where these planes have been. And rather than only knowing the current location of each plane, we get a timeline of where the plane's been around the world and its current location. Now, speaking of alternate architectures, has anyone here heard of CQRS at all? Yeah, this event sourcing is mentioned almost in the same breath when people talk about CQRS, but I don't know if I have enough time to do both. And we have the tools available to us in the Groovy world, in the JVM world, to create these nice event-based systems. Grails async, Ratpack, Netty. Netflix released a tool called RX Java with a Groovy adapter, which does some great pub/sub event-based tooling. It's very nice. So, if we're dealing with events, we have to also talk about how we persist them. So again, rather than persisting the actual object, we persist the events and what happened, what the event did. And so there's two primary entities in an event store. There's the concept of an aggregate, which is like a domain instance, but it really is just to maintain a container around the events and the stream of the events. So for example, a specific user's shopping cart will be one row in our aggregate table, but the events themselves will be tons of them. So the actual aggregate object is very minimal. It maintains a unique ID, so we can reference it and pull it out of the system. It maintains a type, so we know what type of aggregate it was, and a revision. And the revision maps to the most recent event count. So it's a bit like the version variable in a Hibernate or Grails table. And then if you need anything else, you can fully add meta information to these tables that help with your system in general. I like to add a display name. So if I'm getting a list of, say, carts or airplanes, I can then, rather than doing another query to figure out from the events what the thing is called, just display the list of names. The second item are the events themselves. So the schema is also very small, but this class has a lot more functionality. So an event has a foreign key relation to the aggregate ID, and it has a type, so we know what type of event it was, arrival, departure. It has the number that it is in the time stream, and it has some sort of serialized representation of what it was doing, so that we can, when we play these events back, we can rehydrate the information into an event. And then a date created, so we know approximately what time the thing came in. And as for, the class itself should have some variation of methods, a process method, which takes an aggregate and applies the state change to it. A serialize function that takes the event and converts it into the data field in the table, and a hydrate function, which takes a row from the table and is able to turn the event into an instance memory that we can apply. Now, to apply these events, there's a third class that we should use called an event loader. This is a convenience that helps us figure out as we load the objects from the database what type they are, so to know which class to push the event data into. And so the common scenario is if I want to get my current state, which is probably what you're most likely going to be using this for, or most often going to be doing, is to get the ID of the domain object or the aggregate that we're trying to load, and then grab all of the events out of the database, and then run through this event loader, which looks at the type on the database or on the row, and then maps it to the appropriate event, and then builds up the current state brick by brick, step by step. Now, you may be asking yourself, if we have a ton of events, that's going to get kind of expensive to go through all of these events every single time we want to get the current state, right? What if we have a system that has hundreds of events for a particular item, or millions? So it would not be efficient to load all of them. And if you thought that, you're absolutely right. So there's a built-in, or there's an optimization that is also should be built right along with these tables, and it's called snapshot. And so this is a bit of a ironic moment here, because exactly what a snapshot does is save the current state of the item at the given time, which is the entire thing I've been railing against, and I hope no one points that out. So a snapshot is a third table which holds the state of the item at a given moment in time. And there's different techniques for when you generate a snapshot. Some people do it, say, once a day. Here I'm doing it every 3 events, which is way too often. There'd be way too many snapshots. But what this allows us to do is then, if I want to get the current state, I get to start here and then only load that event. So it cuts down dramatically on the number of events that you're processing if all you want to get is the current state. And if we implement this snapshot, which it should, we update our existing models slightly to add, so on the aggregate we get the ability to serialize the snapshot function. So that serializes the current state of the object into JSON or something that we stuff in the database. And then a apply snapshot, which can take the same JSON and then rehydrate the object back into an instance. And then the snapshot table itself is, again, very minimal. Just a foreign key relation to the aggregate ID, the revision that it was taken at, and then a JSON or some serialized representation of the current state at that given moment. Now that's all fine and wonderful. But what sort of data should we put it in? These are very small tables. There's not a lot of relations. So in using these tables, there's only going to be a handful of queries, right? I'm going to have, it's an entirely additive process. There's no updates. I'm never deleting anything. I'm only storing everything that happened. And everything that happened is a bit of information that I want to have, and at no point can I modify that. So my database becomes 3 queries, add an event, add an event, add an event, read the events, and update the aggregate. So there's not really a need for an ORM anymore. And it's almost entirely database agnostic, right? I don't really have to worry about terribly too many relations. I don't really have to, there's no real transactional information. Actually, that's kind of a downside. If you use this technique, you lose the ability to use database level transactions. But the one thing I would advocate, if you do store it, use a relational database, even though there's not that many relations. These systems are designed for, quick adds. And if you're trying to convince your boss or people at your company that you want to go with this radically different architecture, and they're not already on board with, non-relational databases, trying to convince them to do both might be very difficult. So that being said, I use who here has used Mongo at all? I've been using a lot of Mongo recently. Mongo's great, right? It's perfect for things that have a ton of joins in them. An example like a product in a store, in an e-commerce store. Let's say you have a product that may have several shipping units or SKUs. I don't know if we use the same word here. That might have different variations on size and color and things like that. That can be a lot of hierarchical information. I once worked with a client who was an e-commerce store, and they were it took them 12 joins to get a single product out of the database. That's 12, right? For every product. Now imagine displaying a whole list of products. Right? So we were trying to convince them to use Mongo. But Mongo's great for that sort of information. You store the whole product information with one document. However, it's not good for bunches of small little information that you're rapidly inserting. So instead, I'd recommend Redis. Has anyone used Redis here? Yes, Redis is fantastic. It's great for these small little objects in memory, rapid inserts. It also does publish and subscribe, so you can work that into your event system too. Fantastic. So I've got a little bit of a demo here. Let's see if this works. So I'll show this to you first and then some code. So I implemented a little shopping cart, or a little e-commerce store. Where's my little thing? Oh. Hold on. Hopefully the demo gods will be nice to me and this isn't shut down. So I'm going to log in as shopper. Password is password. Now, made a little store called the Greach store. It's got a little counter up here with my little cart information. Current cart is empty. It's demanding that I add things to it. So if I scroll down, there's a lovely non-necessary parallax effect there. So let's say I've got product, shoes, again, really like coffee. Some jeans. Let's say I want to add some jeans to the cart. You can see the counter increase with the amount of products that I have. Let's see, add a pair of these shoes. I really like this shirt. Let's add 5 of them. And I can do that. And another pair of pants. Oops. Great. You see the number increase. Now if I look at my cart, it's exactly what you might expect that your shopping cart would look like, right? So if done correctly, this stuff should be transparent to the user. All they're seeing is what they expect, the amount of products and the type of products that is currently in their cart. And if they want to go in here and if they want to, I only needed 1 pair of jeans and maybe only 4 of these shirts. And then, maybe I'll check out and buy it. So then it processes along and, hey, thanks for your purchase. Now buy some more things. So, that's great. The user didn't notice anything. But in the meantime, what we were doing is capturing everything they did. So I was hoping to get like a nice little graph here, but I didn't have enough time and a bit of jet lag, so I couldn't do it yesterday. But your administrators can go, or your managers can go through and see the frequency and the rate and the time of everything that users are doing in your system. So imagine this information plotted out not just for one user, but all of them. You could see the time of day that people are buying things, maybe add a little sale in. You can see how quickly they add something and remove it. It's very useful. Now, how is this done? Luckily, let me drag this over. So I've created a, oh, this is so big. I'm gonna sit down for this one. Get ready. All right. Oh, this is hard to read. Let me close some of these. Close all. So I've created a Groovy, or source Groovy, package that's outside of a Grails application. So a Grails application is utilizing my event store written entirely in Groovy. So I created an implementation of event store in H2. And so it's not a lot of code. So I'll zoom in on some interesting points here. So this entire class is essentially my ORM now. So I have this H2 event store, which implements event store. I'm gonna, if anyone's interested in this code, I'll put this up on GitHub and show a link. Here's the code for creating my tables. Right? It's 3 SQL statements to set up those the snapshot table, the events table, and the aggregate table. There's 3 queries down here for actually inserting the events, updating the revision number, and updating snapshot. Loading the events, if I'm scrolling too quickly, let me know, or if the text isn't too blue. And loading the events is just a matter of calling this replay function, which basically just goes through and selects the events from my aggregate ID and orders them by revision number. And there's also the snapshot convenience, which just selects the most recent snapshot. It's very, very minimal. The real work comes in at a function down here called insert, which should probably be a stored procedure because there's a massive race condition right here. We get the aggregate and the expected revision that it should be. So a bit like, again, the version field in your every Grails table that you've seen, and a list of the events. We check to see that that we actually got events, and that the current aggregate is at the expected revision. And if it's not, we throw an error, revision not equal. But what's interesting here is that we don't necessarily have to throw an exception. If these 2 events that are in conflict, let's say we got some events out of order, if those 2 events are changing different fields, let's say we had one event that was updating a user's name and the other one was updating the user's address. If they came out of order, we might throw an exception, or we could do something smart here and look and be like, oh, well, he's updating the name and the address. Those 2 different things, it's fine. So that's sort of an interesting little side thing that I didn't have time to implement. And then if the events pass, we basically just go through, process them on the aggregate, and save them to the database. It's very simple. The actual aggregate object itself, that's the interface. So I created a shopping cart aggregate, which is, it has a few fields. It looks maybe like your standard domain model, but it's outside of Grails, and we never actually save this directly. We have a snapshot function, which basically just uses JSON builder to turn it into JSON, save it to the database, and an apply snapshot data, which knows how to take that JSON, extract the relevant fields, and apply it to the model. The actual events themselves, like add item, it has the, I should have put final there, it's embarrassing. They have the type so that the loader knows how to extract them, and it has a constructor, and it has the process function. And the process function just goes through and increments the item count and updates a map of the SKUs on the object itself. Created event assigns a user ID. It's really just a representation that the thing was created. Purchase event. This is where we would do. This is where we clear the cart and possibly send off to billing somewhere. And the remove item is just like you might expect. It removes the item from the cart. which is it's all very minimal. And the shopping cart event loader it just specifies all the events that it might see, and then it extends a base event loader, which just knows to call into the store to grab the events at a given revision or grab the snapshot. Finally, there's a service. Wow, this is getting close. This is not very well commented also, which is also embarrassing. But the service here is basically, very simple. Just if I'm adding an item, I get the product, I create a new event with the SKU and fire it off into the system. It's very minimal. Any questions so far? All right. So let's go back to the slides. So the real question, should you be using this at all? And I argue that no, you shouldn't always be using it. It's not useful for everything. Stuff like a blog post probably don't need to have all of the information that was done to it over time. Stuff like a user role doesn't need it. But what you should really be thinking about is for business critical applications where knowing the time can give you a distinct advantage. If the core of your business is based around some data model, this should be there. There's a distinct advantage of having that you can use for analytics later. And if you do adopt this technique, it'll certainly make Bob happy. That's all I've got. Thank you very much. Does anyone have any questions? Margot. I did not. Look at me being a bad open source citizen. So yes, that's a great idea. I'll take a look at that if anyone's interested. Hey, anyone else? Hmm? Mm-hmm. Pivotal. So we do a. It's funny you mentioned that. I'm giving a talk on reactive architecture tomorrow. So I was trying to keep things focused entirely on Groovy, but we in Boston I helped to organize a reactive meetup, and we do talk about some reactor stuff. We're big Scala and typeface fans too. Anyone else? No. All right. Well, I don't want to keep you late for the party, so there's we got a few more minutes left. So thank you for your time.